Welcome to the Morningside Institute 2022 Winter Week 9 solution video. Problem 1. According to the following figure, how much does each lemon weigh? On the left side, there's 4 lemons and a 3. And then on the right side, there's 2 lemons and a 9. So as you can see, there are 2 lemons on each side. If we get rid of the 2 lemons from each side, then we'll have lemon plus the 3 equals 9. So if we subtract 3 from both sides, subtract 3, then we'll have lemon plus lemon equals 6. Then lemon will equal 3. Problem 2. Catherine bought n candies. If she counted by 3, there's 2 left. If she counted by 4, there are 3 left. What is the smallest possible value of n? Let's start counting by 3. So if there's only one 3, then we do 3 plus 2, and then there's 5. If there's 2 3s, then it's 3 plus 2, and that is 8. If there's 3 3s, then it's 3 plus 3 plus 3 plus 2 equals 11. Now let's try counting by 4s. If there's only one 4, then it's 4 plus 3, and that's 7. If there's 2 4s, then it's 4 plus 3 equals 11. So as you can see, 11. So that means the smallest possible value will be 11. Problem 3. John and Natasha start from the same point at 9 o'clock and walk in opposite directions. Natasha walks 4 kilometers per hour and John walks 2 kilometers per hour faster than Natasha. How many kilometers are they apart from each other at noon? Natasha, which I will just put N, walks 4 kilometers per hour, and John, I'll put J, walks 4 kilometers per hour plus 2 kilometers per hour. Okay, so that means John walks 6 kilometers per hour. Since noon equals 12 o'clock, 9 to 12 is 3 hours. So they will be walking 3 hours. If they start from 9, this will be the starting point. This will be 9, and then this will be 12. 12. Okay, so if Natasha goes this way, and then John goes this way, since Natasha is walking for 3 hours, since she can walk 4 kilometers per 1 hour, then you should add 4 3 times. So 4 plus 4 plus 4 equals 12. Okay, now let's do John. So if John walks 3 hours and he can walk 6 kilometers per 1 hour, then we should also add 6 3 times. So 6 plus 6 plus 6 equals 18. So Natasha walks 12 kilometers and John walks 18 kilometers. So 12 plus 18 equals 30. So they'll be walking 30 kilometers. Problem 4. How many 3-digit numbers can be formed by using 2 digits from 1, 2, and 3? For example, 112 and 323 are such 2 numbers. We're going to list all of the numbers out. So first one, we're going to do a 3-digit number with 2 ones. So for example, blank 1 1 or 1 blank 1 or 1 1 blank. So first one is 211 and then 311 and then 121 and then 131 and then 112 and 113. So this is all of the 3-digit numbers that use 1 as the 2 digits. So there's 6 of them in total. Okay, next we're going to list all of the 3-digit numbers with 2 as the 2 digits, and it's going to be blank 2 2, 2 blank 2, and then 2 2 blank. So it's going to be 1 2 2, 3 2 2, 2 1 2, 2 3 2, 2 2 1, and 2 2 3. And if you count them up again, there's going to be 6 as well. Okay, now we're going to list out all the numbers that has 2 3s. So blank 3 3, 3 3 blank, and 3 blank 3, 1 3 3, 2 3 3, 3 3 2, 3 3, 1, 3, 1, 3, and 3, 2, 3. So there's, if you count them up, there's also 6 numbers. So if you look at this one, and this one, then there is 6 plus 6 plus 6. So 6 plus 6 plus 6 equals 18. Homework 2, problem 1. The chairs on the main ski lift at Thurbo are numbered from 26 to 100. How many such chairs are there? So 26 to 100. So we can do 100 minus 26 plus 1 equals 75. So the reason why we have to add 1 is because we always forget to count 1. So for example, if we're doing 21 to 23, there's 21, 22, and 23. 21, 22, and then 23. Then there's 3 numbers, right? But if we subtract them, then we do 23 minus 21 equals 2. So we're always missing 1, so we have to add 1 at the end. That's why it is 75. Problem 2. 2 ordinary 6-sided dice are stacked on top of each other and placed on a tabletop. What is the sum of all the visible faces in the following picture? What is the sum of the dots on all the invisible faces? For a regular die, the sum of dots on 2 opposite faces is 7. Okay. So the first question is, what is the sum of the visible dots? So this one is 1, this one is 4, this one is 2, this one is 5, and this one is 6. Okay, so 1 plus 2 plus 4 plus 5 plus 6 equals 18. Now let's do the second one. So it says, what is the sum of the dots on all the invisible faces? So it says that the 2 opposite faces equal 7. So the one that's opposite to this 1 is 6. The opposite one to the 2 is 5. The opposite one to the 4 is 3. And then the opposite one to the 5 is 2. The opposite one to 6 is 1. And then since we don't know the top and bottom for the bottom die, we only need to know they add together to 7. So there's 7. So 1 plus 2 plus 3 plus 5 plus 6 plus 7 equals 24. Problem 3. Which of the following can be folded into a cube? So for this problem, you kind of have to have some imagination, and you're going to have to play around with cubes, or you can just make it. So the answer is the last one, and I actually made a figure in real life. I will show you the last one can be made into a cube. So let me fold this. And so here. So you can make these by measuring with a ruler, or you can use what I used, sticky notes, and I taped them together to make into like the figure that you want it to be. And so as you can see, this is a cube. Okay, problem 4. Patrick is 12 years old and his father is 43 years old. What is the age difference between Patrick and his father after 21 years? After 21 years, that means you have to add 21 to both numbers. So 12 plus 21 equals 33, and then 43 plus 21 equals 64. And 64 minus 33 equals 31. Okay, that is method 1. There's another method. So method 1 is right here. And then method 2 is, since they're adding 21 to both ages anyways, then we don't have to add them because their age difference will always be the same no matter how many years you add to them. So we can just do 43 minus 12 equals 31. That's method 2. The second part to this question is, after how many years Patrick's father will be twice as old as him? Since the age difference is 31, then you can do 31 minus 12 equals 19. So that is, after how many years will Patrick's father be twice as old as him? Homework 3, problem 1. The fifth graders at my local school were surveyed to find which one of the 4 teams in the local football competition they followed. For the butcher birds, there were 8 followers. For the gangs, there were 6 followers. For the lorikeets, there was 2 followers, and the rosellas had 4 followers. So the most popular was the butcherbirds with 8, and the lorikeets with 2 were the least popular. So 8 minus 2 equals 6. Problem 2. Which of the following sentences correctly describes the picture? So the answer is C, because there's 4 circles, and 2 triangles. Okay, now let's see why the other answer choices cannot work. So for A, it says that there are as many circles as squares. There are 4 circles, but there are only 2 squares. So that cannot be true. Okay, now for B, there are fewer circles than triangles. There is only 2 triangles, but there's 4 circles, so that does not work. Okay, for D, there are more squares than triangles. There's 2 triangles and 2 squares. That means they are the same, so there isn't more squares than triangles. And for E, there are 2 triangles more than circles. It's actually the other way around. There's 2 more circles than triangles, but there isn't 2 more triangles than circles. Problem 3. James has several cats. If his cats have 12 more legs than noses, how many cats does James have? Okay, there's 2 methods to solving this. So for method 1, you can just use guess and check. Sooner or later, you'll find that there are 4 plus 4 plus 4 plus 4 legs. And then there is 1 plus 1 plus 1 plus 1 nose, 4 plus 4 plus 4 plus 4, minus 1 plus 1 plus 1 plus 1 equals 12. Okay, so method 2. We can find that a cat has 4 minus 1 more legs than noses because there's 4 legs and 1 nose. So this is 3 more. His cat has 12 more legs, then we can do 3 plus 3 plus 3 plus 3 equals 12. Then we know that there are 4 cats. Problem 4. 6 different digits from the set 1, 2, 3, 4, 5, 6, 7, 8, and 9 are placed in the squares in the figure shown so that the sum of the entries in the vertical column is 23 and the sum of the entries in the horizontal row is 12. The sum of the 6 digits used is, we're trying to find the sum of the 6 digits. Okay, so it shows that this row added together is 23 and this row is added together is 12. Okay, so the only combination possible that adds up to 23 will be 6, 8, and 9, but that doesn't mean 8 is where it should be. So let's erase this. So let's write it down here, 6, 8, and 9. For example, if 9 was here, it wouldn't be possible because they can only be used once. Since 12 minus 9 is 3, the only way for this to be possible if it's 1, 1, 1, but you can't use 3 ones, so that's not possible. Okay, now let's try 8. 12 minus 8 equals 4. This is also not possible because you have to use 1, 1, 2, and you can't use 2 ones. So 8 is also not possible. So that leaves us to 6. So 6 is actually the only one possible because you can do 6, 1, 2, 3. So 1, 2, 3, 6, 8, 9 is the digits that will be used in this problem. A4 problem 1. This following square grid can be divided into 3 shapes made from small squares. If 2 of the shapes are these 2, then the third shape is A, B, C, D, or E. So these are the 2 shapes, and then one of them from A, B, C, D, E are going to be used. So let's first draw a grid like this one right here. And then we can figure out where to put these 2. this one, and this one. So for this one on the right, we'll put this right here. And then this one on the left, we can put right here. And then this shape right here is actually just B. As you can see, if you tilt this right here, then it will just be this. So this right here is actually B. So the answer is B. Problem 2. Fred has a bag of nickels, dimes, and quarters. What is the least number of coins that he can use in order to pay a 70-cent pencil? Nickels are 5 cents. Dimes are 10 cents. And quarters right here is 25 cents. Since quarters is the most, then we'll start with quarters. So 25 is less than 70, so we can add another 25. This equals 50. And if we add another 25, that will be more than 70. So we cannot add another one. So now let's move on to dimes. 50 plus 10, that's 60, plus another 10 equals 70. So in total, we use 2 quarters and 2 dimes. So this is 4 coins. Problem 3. Find 4 consecutive numbers. A is less than B, that is less than C, and less than D. So we can play around with the numbers, and we'll find that CD plus CD equals 1AB. And so CD will be 78, and then plus 78 will equal 156. So A is going to be 5, which is smaller than 6, which is smaller than 7, which is smaller than 8. Problem 4. There are 25 students in Mr. Street's class. 15 of them are attending after-school academic enrichment programs, and 16 of them are attending after-school sports activities. 5 of them attend neither. How many of them are attending both academic programs and sports activities? So we can draw a Venn diagram, and this will show us which is overlapped. Okay, so this is called a Venn diagram. And so this part is going to be the 15, and this part is going to be the 16. Since there's 25 students in total, but there's 5 that are not attending neither, then 5 will be outside. Now we're trying to figure out what is this overlapping part right here. So since there's 25 students, but there's 5 that's not attending, so there's 20 students who is attending either the academic one or the sports one. And so since we're trying to figure out what is the overlapping, we can do 15 plus 16, which is 31. And then we can subtract 20 from 31. So 31 minus 20 equals 11. So 11 students are attending both. Day 5, problem 1. Compare the size areas of the following 2 polygons. Are they equal? If not, which one is bigger? Okay, so first, let's count the area of the 2 polygons. Let's count how many full squares there are in the first one. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 full squares, and then these 2 small triangles added together is 1, and then these 2 added together are also 1. So the first one equals 12. Okay, now let's look at the second one. There is 1, 2, 3, 4, 5, 6, 7, 8. 8 full squares, 8. And there's these 2 is plus 1, these 2 is plus 1, these 2 plus 1, and these 2 plus 1. So this equals also 12. So they are equal. Problem 2. The number of cars in the family of each child in a class is recorded. Okay, so we're trying to figure out which statement is true. A is 2 families have 2 cars each. B is 6 families have at least 2 cars each. C, 4 families have exactly 1 car each. And D, every family has at least 1 car. And E, 3 families have exactly 2 cars each. Let's look at the graph. And so 2 family has 0 car. 8 families has 1 car. 4 families have 2 cars, and 2 families has 3 cars. The right answer is B, because it says 6 families have at least 2 cars each, and this is 2 cars, and then this is 3 cars. And so 4 plus 2 equals 6. Okay, now the reason why A, C, D, E doesn't work is because, so for A, 2 families have 2 cars each. That's not true because it's 4. And then C is 4 families have exactly 1 car each, but there's 8 families who has 1 car each. D is every family has at least 1 car, but there's 2 families who have 0 cars. And E is 3 families have exactly 2 cars each, and there's 4 families who has exactly 2 cars each. Problem 3, magic trees grow in a magic garden. Each tree contains 6 pears and 3 apples, or 8 pears and 4 apples. If there are 10 apples in the garden, how many pears are there in the garden? So the only combination for there to be 10 apples in a garden is if there's 2 trees with 6 pears and 3 apples, and one tree with 8 pears and 4 apples. Okay, so then the number of pears would be 6 plus 8, and this equals 20. Problem 4. 3 friends A, B, and C divide 18 apples. A said, I get 5 apples. B said, the number of apples I get is an even number. C said, the number of apples I get is an odd number. If exactly one of the above statements is not true, which one? So A's is not true. Okay, let's see why. If B's is not true, then they will have an odd number. Then 5 plus odd, that will equal an odd, but 18 is even. So that is not true. Okay, now let's look at C. If C's is not true, then C will be even. Then even plus 5 plus even will also equal odd. So since 18 is even, so B and C won't work, so it is A.